Hello and welcome in. Mark here, aka the Markster. This is video number 44 in the FreeCAD series. I decided I'm going to go back and redo the previous video, the dividing head plate, and show how to make this in the part workbench. And the motivation for that, I suspect there'll be a few new users who will be downloading this model, and it's not quite as robust as I would like, being made in part design. So if you, for example, if you reduce the diameter of the disc such that the outer rings no longer fit, it's going to break that model. But if I make this again in part design, it will be more robust to those types of issues. So I'm gonna save this file as file 44. Binding head V2. And I'll delete this body, but I'm gonna save this DD property object since we have all of our properties already set. And we'll switch to the part workbench. Now to make the, let me show you which version I'm using here. This is 0.19 revision 19758 on Windows 10. So FreeCAD has a stable version 0.18 and a version that's under development. 0.19 is currently, we're in that 0.19 development cycle. So this is one of the more recent snapshots of that source code that's been compiled. I'm sure there are some newer revisions out within the last week or two. I think I updated this one about a week and a half ago or so. Alright, so we're going to make our disc first, the outer disc, and we're just going to use this cylinder. And I'm going to relabel this to disc. And we'll set its radius to this diameter divided by 2. And we'll set its height. That's going to be disc height, this thickness. Alright, and now another disc, another cylinder for the shaft. So I'm going to call this shaft hole. And it will be, go back and watch the other video if you haven't watched it, because that's the one in which I set up all of these properties here. So we divide it by 2 since it's the radius that we need. And we'll set this height to the thickness. Alright. Now we'll do a Boolean cut on this later on. Let me just show you. When you do a Boolean cut, you get the hole. But I'm not going to do it yet. I'm going to wait. I'm going to undo that. And I'll do all these Boolean cuts in one go at the end. So the next thing now is that hole pattern, the mounting hole pattern. So let's insert another cylinder. And this will be, what do we call this? Mounting something. Mounting hole diameter divided by 2. And the height is going to be that thickness. Alright, and now we need to move this with the placement property along the x-axis, and that's going to be that mounting hole what do we call that? Mounting hole, mounting ring radius. Alright. This is our view from the front. And from the bottom, let's see. Yeah, it's a little better. So this cylinder is the mounting hole. We've got the radius set to mounting hole diameter. We've got the thickness height set. And we've got the position out to the ring radius. Mounting ring radius. And now we're going to make a draft workbench polar array. And we need to select the array here and turn it from ortho to polar. And we need to come down to number of polar, and we'll set that to mounting hole pattern, wasn't it? Alright. So I'm going to call this mounting hole array. Now I'll call this cylinder mounting hole. Alright, and we'll cut this out later. Now we also need to do our counter bore there, and we'll use a cylinder for that, a cone for that. You see the cone. Let me call this, I pressed F2 to do this relabeling, and I'm going to call this bore, a counter bore, right? Just call it counter bore. There's only one counter bore in this model. And the radius 1 is going to be the mounting hole diameter divided by 2. And the radius 2 is going to be that bore, kind of bore diameter divided by 2 again. And the height is going to be this thickness. Alright, now let's move. No, we don't want all the way this thickness, do we? We want this thickness minus, actually we just want, let me see, we just want the bore depth. There was a bore depth. Let's see if I can find that here. Counter bore depth. That's the height we want of this little guy. Yep, and now we need to position it on the x-axis. Position the same way we did the mounting hole. So that's going to be that mounting hole radius, mounting ring radius. And let's put it hopefully in the right spot. Let's view from the top here. Yeah. And now I'm going to make this, I'm going to delete this mounting hole array and redo it. But first, I'm going to fuse these two objects together. Alright, so this fusion object is the mounting bore hole. Mounting hole counterboard. Alright. Now let's just cut that out and make sure that we're looking like we want. And we're not, are we? And do that cut. Let me hide the disk temporarily, see what we're looking at here. Okay, so I see the problem. We need to move this cone up some in a Z direction. Got to do that. So I'm gonna move it up this thickness, and that'll be a minus value, plus then the counterboard depth. See if that's going to position it. Nope, that's not what I want. I'm not doing this right for some reason. Let's see, not minus there, minus this, right? Let's see what that's going to do. F5, yeah, that's what I want. That's what I want. Now let's show the disk again, and let's do that cut to see. Yeah, that's what we're looking for. I'm gonna undo that cut just by pressing delete. Like I said, we're gonna do all these cuts at once. Now I want to go ahead and make that array again. And that's going to be a polar array, and the number of polar will be the mounting hole pattern. All right. Now go back to part workbench and add a cylinder, and this will be the ring 1 cylinder. Let me call that ring 1 hole, and this radius is going to be a small hole diameter divided by 2, and this height will be this thickness. Basically the same process. It's just the advantage of this technique is if these outer rings don't fit, it's not going to break the model like it will in the other workbench in part design. So I'm going to move this one out now on the X, and that's going to be the ring 1 radius, wasn't it? And we can't do one single array. We can put all these rings in and do a single array in this workbench to encompass all of the rings. No, the problem with that would be we need a different hole pattern for each, so that wouldn't work. You can see how carefully I've thought this through. Let's go now to this array, and we'll turn it into a polar array. By default it's ortho, which the ortho is a rectangular array, and this will be a ring 1 hole pattern. Alright, and now this time I'm gonna just add all of the let me rename this 9-hole array so we don't get too confused. And this will be ring 1. I could probably leave it alone, huh? Array 1 will be ring 1. So that's going to work for that. And this will be a ring 2 hole. I'll make it ring 3, ring 4, ring 5, ring 6. This will be ring 2 hole. Uh-oh. This is not ring 1, is it? Yeah, it is ring 1. This will be ring 3. Ring 3 hole. And this will be ring 4. This will be ring 5. Uh-oh. F2. F2. Ring 5 hole. I hit the wrong key. And this will be ring 6 hole. Alright. Now ring 2. Let me see if I can make all of these the same radius at once. No, it won't let me. It won't let me link it parametrically if I do them all in one go. So one at a time. And this is that small hole something. Small hole diameter divided by 2. I'm going to hit Control C and copy that to the clipboard. And I'll do each of these, just doing the first, that radius. Control V to paste it in. So that's going to speed things up a little bit for me. Control V, because I copied that formula to the clipboard with the Control C, and now I'm pressing Control V on the clipboard just to speed this up a little bit, because they're all the same diameter. Alright, and they're all going to be the same height as well, so we can do that too. The height will be this thickness. So let me highlight this, and I'm just going to copy that. Press OK, and go to this one. Control V to paste it in. Enter again. Control V, enter. Control V, enter. And the last one. Alright. Now we need to move these out. The ring 2 position. That's going to be what? The ring 1 radius plus that separation property, which is ring separation. I'm just going to put times 1, and then I'm going to copy this one too. Boy, I'm getting lazy today. Copy that. Yep. And this one will be positioned the same way with one little modification, times 2. So the way we're positioning these is this ring radius plus the separation times 2 or times 3 and so on. See, this one is going to be, let me spread this out some, separation times 2. So the next one will be separation times 3. And that's that x coordinate times 3 on this one. So I'm just saving myself a little bit of typing. Times 4 on this one. And times 5 on this one. Alright. And now we'll go to draft menu, draft workbench. This is where we make our arrays at. So we'll select the ring 2 hole and make the array. Turn it into a polar array. And a number polar is the ring 2 hole pattern. And we'll do the same with ring 3. And we need to turn it into polar array. And this will be ring 3 hole pattern. And we'll do ring 4. Polar array. Number polar. Ring 4. Where you at, ring 4? Ring 4 hole pattern. And ring 5. Click the create a polar or rectangular array. And let's see, the array type is polar. And a number polar. And this is ring 5, so we'll look for a ring 5 hole pattern. And we got one more to go. And that's ring 5, ring 6. And we need to set that to polar. Alright, so now we're ready to make the cut. And what I'm going to do is I'm going to select all the objects that are to be cut away, and I'm going to fuse them with the part union right here, this one. Make a union. So we're fusing all the parts to be cut away. So these are the cutaway parts, cutaway bits, right? We'll select the disk first. This is the base object. You always select when you're doing a cut, you always select your base object first, hold down the control key, and select your cutting tool second. So our cutaway bits is our cutting tool. And then we do the cut. And hopefully we get a good cut. Alright, now the beauty of this one is, let me change that disc diameter to something small enough to where all the rings can't fit. And hopefully it won't turn me into a liar. Yeah, you see, it did not break the model. Now it's too small for all the rings to fit, but you're not getting errors like you would have gotten in the other in the part design workbench. So I kind of regret now making that in that workbench. But I'm teaching that workbench, so that was the motivation. Let's put it at 6 inches for the disc diameter, and we'll refresh that. So you see, it's much more robust. Even though it's not exactly the model we want, it's not breaking. So now we can go in and set the separation Where's our separation at? Make this a little smaller to squeeze these together. We make it 3/16 and just see what happens. So is that too close? I don't know. And we can certainly bring in that first ring. Where's that ring 1 radius? In a little closer as well. So instead of 2 inches, let's make that 1 3/4. And then refresh that. Yeah. So it's just a more robust workbench to work in than that other workbench, even though that's the one most people tend to favor using. This is one example where this part design is just not as good as this part workbench for this particular model, in my opinion. So let me go ahead and wrap this up and call this video complete. I thank you for watching, and as always, have a great day.